Okay, so I'm going to quickly go through all of these problems, okay? Every class ended in a different place, so I'm just going to go over these. Now please pause the video at some point and just try to do any problems that you can on your own, then come back and review or check the answers and listen to the explanation. Number one, which linear equation is not, so pay attention to that word, in slope-intercept form. So y equals mx plus b is slope-intercept. Why is it called that? Because here's your slope and here's your y-intercept. Okay, so let's see. You're looking for the y being by itself, then you have the equals, then you have your mx, and then you have your b. So here already this is not in slope-intercept form because this should be on the other side. This is not in slope-intercept form. That's probably the answer. Let's double check here. Yeah, y equals mx plus b. This lines up, lines up, lines up, lines up. That's fine. Here, y equals mx plus b. Yeah, because here the m is 1. So y equals mx, and then plus 0 is your b. And then here you have y equals mx plus b. Y equals mx plus b. So it's in slope-intercept form. The only one that's not is this. This is more like y plus mx equals b. That's not in the correct form. Number two, which one represents a line? Remember, you're looking for exponents of 1 and then none of the variables are on the bottom of a fraction. So exponent 1, good, but this one's exponent 2, so that's out. This one, exponent 1, good, but this one, exponent is on the bottom. This x is on the bottom, which technically means it's x to the negative 1. So because of that, that's not a line. This one, exponent of 1, hey, that's fine. Yeah, there's no y, but it's still linear. It's actually a vertical line. We'll come to here. That one is not because of this exponent being 3. So C is the correct answer. Number 3, if at any point I'm going too fast, okay, I'm trying to go quickly, but you can always repeat, okay, if I'm going too fast, you can, go back. Number 3, the two equations below describe two different relationships between x and y. Okay, here we go. Oh, it looks like they're both, thankfully, in slope-intercept form, which makes life a little bit easier. And here, since you don't see the v, it's invisibly a 0. So here, the slope is m, the y-intercept is 3, the slope is 5, the y-intercept is 3, the slope here is 1/5, and the y-intercept is 0. Okay, equation 2 has a greater rate of change. Hey, that is your slope. M means slope. So, is that true? No, because 1/5 is not greater than 5. You can put this in your calculator, and that's not greater than 5, so that's false. Equation 1 has a greater rate of change, greater slope than equation 2. Is that true? Yeah, that's true. I'm going to probably pick that one, but I'm just going to double check that it's not possibly C or D. Equation 2 has a higher initial value. Remember, initial value is your y-intercept. So y-intercept, initial value, they mean the same thing. So let's see. Higher initial, this is 3. The initial value is 3. The initial value is 0. So this one's higher, but this one's saying equation 2 has it, so no. Both equations have the same rate of change. No, because the rate of change here are 5 and 1/5 are not the same. So yes, B was correct. Number 4. The equation and the graph on the right describe two different relationships between x and y. So there are two different relationships. So which statement most accurately describes and compares the two relationships? Okay, so this is a different line than on this one. This is a different equation than that one. I'm going to darken the x so you can see that better. And I'm going to darken the y-axis. Okay, which statement most accurately describes and compares the two relationships? The rate of change, hey, that's slope. For both the equation and the graph are the same. So let's see. The rate of change here is -4. The rate of change here, let me pick 2 points. Down 1, that's negative. Right 4. Well, which one's the change in y? Because it's rate of change is always change in y over change in x. So -1/4, which is -1/4. Let's compare these two. Which one has a greater rate of change? This one does because it's a higher number than 1/4. Don't worry about the sign. So they're not the same. So it's not A. The rate of change, so we're looking at slope again, is higher in the equation is higher than the rate of change in the graph. Yes, that's true. Equation 2 has a higher initial value. Okay, here's my initial value for the equation 1. The graph, we have initial value of 0, 3. They're actually the same. Okay, so that's not true. Both equations have the same rate of change, which is basically what A said, and that's false, so B is correct. Cross out 5, because that's exactly the same as number 2. Number 6, what is the slope and y-intercept of the equation y equals 2x? Is it in slope-intercept form? Yes. Then we can identify it. So here we go. There's our slope. So m equals 2. It's not that. So these are out. And then the y-intercept is 0. So 0, comma 0. A is the answer. Number 7. The table and equation below describe two different relationships between x and y. Okay, here's a relationship and here's a relationship. These don't go together. It's like, let's verse them. How are we going to compare them? Which statement most accurately describes and compares the two relationships? Okay, rate of change, that's slope. Okay, for both the table and equation are the same. So let's talk about the table. You can do, since this is a line, don't worry about checking every one of them. You can just pick one. So if you want to do x1, y1, I need to go vertically because these are all x's and these are all y's. And then this is x2, y2. You can do that, or pick any of these other ones. Okay, and then you can do y2 minus y1 over x2 minus x1. And then figure out the slope. That's your slope. But you can also do it this way. If you're comfortable, you can do change in y this way. How did it change? You added 4. How did this change? You added 1. So what is the change in y over change in x? The 4 goes over 1, which is 4. So the slope of this line is 4. And you don't have to check all the other ones because if you're comparing two linear relationships, okay, maybe we should say that two different linear relationships. That will help, right? The county didn't write the word linear, so I left the word linear out, but that might help because then you know that you don't have to worry about checking all of the other ones, okay? But just know that's what they mean. So what we would put here is that we would go ahead and use any numbers. You could have done it here, you could have drawn a number here and here, like -2 to 6, you have to add 8 to get there. And this one you have to add 2. So if you put 8 over 2, it still comes out to be 4. Okay, just a side note. So this was enough. So let me go over here. The rate of change when you have an equation is the m when it is in slope-intercept form. So here it is. There's your rate of change. So the rate of change of the table is 4. The rate of change for this equation is 1. Are they the same? Absolutely not. So it's not A. Now let's look at the rate of change in the equation is higher than the rate of change of the table. Let's see. The rate of change here is higher than this. No, 1 is not higher than 4, so that's false. Oh, now we're talking about initial value. Okay, now let's look at the initial value. Here's the initial value for the equation. Here's the initial value for the table because 0, -2. Is the initial value of the table higher than the initial value in the equation? No, because -2 is not higher than 3. So now it should be D by process of elimination, but let's double check so that we didn't mess up somewhere. The rate of change of the table is higher than the rate of change in the equation. Okay, let's see. The rate of change here is 4. The rate of change in the equation is 1. Is that higher? 4 higher than 1? Yes. Okay. Don't be afraid to take some time on these. Number 8. Which equation is a slope-intercept form? Okay. Y equals mx plus b. So these should look like y equals mx plus b. This one does, this one does, this one does not, so I'm going to X that out right away. And then that one does. So now we got to see which one of these match with that. So you should show work. 5, here's what maybe might help you is we write y equals mx plus b. We know it should look like that. I'm even going to draw my line right there. And if you notice the equals, what you have on the right side of it is just a 21. So I'll write that. And on the left side, on this side, you have a 5x minus 3y. So this doesn't quite look like y equals mx plus b. We need to get this 5x over there, but you have to get rid of it by inverse operation. Okay, so then this becomes -3y equals. Now, please don't say 21 minus 5, oh, that's 16x. No, this is a circle, this is a box. These are unlike terms. They cannot combine. So we're going to put the -5x here, and then plus 21. You might be like, well, why didn't you write 21 minus 5x? 21 minus 5x, it's actually the same, but we wanted to put the mx first. So we're going to put the -5x first, and then this is your b. The b we're going to put here. I'm going to have to extend mine to this side here. So um, I'm still not done because now the y's are lined up, but this negative 3 has to be gone. So I have to divide by negative 3, divide by negative 3, and divide by negative 3. This becomes a positive 1y. Now it's looking more like the top. And then this right here, we're going to simplify it by getting rid of the negative. So it becomes positive 5 over 3x. And then here, 21 divided by negative 3 is minus 7. So be very careful, 5/3. Let's see, that one looks like 5/3. This one's a negative 5/3, so this one's out. And that one's not even a 5/3, so it's out. And let's see here, yeah. The y-intercept's the same and the slope's the same, and it's positive, all of that. So it's A. Be careful of this one. That's a trap, simply because there's a negative here and you want a positive slope. Okay, number 9. What is the slope and y-intercept of this equation? Look. Students say, oh, look at that. That's a number next to the x, so that must be the slope. And look, this is your trap. And I put it here purposefully to see if you guys are really going to pay attention, because you can only say what the slope and y-intercept is if this equation is in slope-intercept form. Remember, that means y equals mx plus b. Well, is it? Y minus 3x, and the equals right here, and then 9. That's not in slope-intercept form. So the y is pushed over here. I need to get rid of this negative 3x by adding it, and don't forget it's a 3x you're adding, not a 3. So make sure you actually put the x in here. That eliminates. Now y can scoot over, and it looks more like the original here. And then I have a 9 and a 3x. You cannot combine these because this one has an x and this one doesn't. That's why we have a circle here in a box. Don't say that's 12x. All you can do with these is write them side by side. So do I write 9 plus 3x or 3x plus 9? You should do 3x plus 9. Both of them are correct, but we want to put the x term first, so the box comes before the circle. So let's write the 3x and then plus 9. Okay, so now we're ready. This looks like y equals mx plus b. So now we're able to identify, oh, there's my slope and here's my y-intercept. So what is the slope? It's not negative 3, it's positive 3. But the y-intercept is a positive 9, so it's not this one. It must be C. All right, number 10. What is the slope and y-intercept of this equation? Well, once again, y equals mx plus b. It's not quite in slope-intercept form because of this 6. So it's held together to the y by multiplication. So you divide, divide, divide. This cancels. And you get 1/6, and then bring out the x. Negative 6 divided by 6, you should check in your calculator, that's a minus 1. And that is in slope-intercept form. Now you know, oh, there's my slope, there's my y-intercept. So slope of 1/6, not that, not that. Okay, so it's either B or D. And the y-intercept is 0, negative 1, it's D. Okay, now let's go to number 11. Compare the graphs of line 1 and line 2 on the right. Which statement most accurately describes and compares the two relationships? Okay, the slope of line 1 is higher than the slope of line 2. Let's see. Find the slope. Okay, I'm going to pick good points here. That's not good. Well, okay, it looks like that's my best option. Let's see. Okay. I would probably, based on the thickness of this line, I'll just go with this very next one. Okay, you could have used basically any of these on the line. Okay, so even if you did, let's say, oh, I like that one, okay, we'll go with that one. So to find the slope, draw your arrows. Now you could use slope formula, figure out what the coordinates are, but it's so much faster with arrows. So I'm going to try going from this point to that point, draw an arrow going up and then to the right. Well, if you're going up, it's positive. If you're going right, it's positive. Okay, so how far did I go up? Your pencil's at 0, then 1, 2, 3, 4, 5. I went up 5. From here, I turn the corner, 1, 2, 3, 4, 5. Okay, so which one's your change in y? Because slope is change in y over change in x. Which one's your change in y? Well, they're both 5. However, the change in y, what if they were not the same number? You would want the correct number on top. It's this 5 because it's vertical movement. And this is your change in x. That comes out to be 1. The slope of this line is 1. Okay? How about this one? I'm going to pick some easy points. That's a good one. And that one looks like a good one. So I go up 2, positive, right 1. So the slope of this line is change in y over change in x, which is slope of 2. So let's check these. So the slope of this line is 1. So is the slope of line 1 higher than the slope of line 2? No, 1 is not higher than 2, so no. The slope of line 2 is higher than the slope of line 1. That's true. Now let's check the others. The y-intercept of line 2, let's see, where's the y? Okay, here it is. What is the y-intercept? It's at 0, negative 3. Now, if it's hard to see, let me get a highlighter. Okay, remember, y-intercept means wherever it crosses the y-axis. So where does the line 1 cross the y-axis? Right here. Where is that? At 0, 3. So that is 0, 3. Where does line 2 cross the y-axis? Right here, which is at 0, negative 3. So the y-intercept of line 2 is right here. Is that higher than this one? No. So that's not correct. Line 1 and line 2, oops, both have the same slope? No, they don't, because the slope of line 1 is 1, the slope of line 2 is 2, so no. So B is the correct answer. And last but not least, number 12, determine which statement is true. A line is increasing when the slope is negative. No, it has to be positive. A line is increasing when the y-intercept is positive. Not necessarily, okay, because look at these. The y-intercepts are different, like one's positive, one's negative, but they're both increasing, so no. A line is increasing when the slope is positive. That's true. A line is decreasing when the y-intercept, no, it doesn't matter. Okay, it's about the slope. So C is correct.